Alright, this is my second attempt on these notes, so let's see how it goes. First time they wouldn't upload. So here we go, 10.4, other angle relationships in circles. So before this, we learned that if the vertex of an angle was at the center of the circle, then the measure of the arc was equal. Okay, the angle equals the arc. The measure of the angle. Measure of the angle equals the arc. Okay, if the vertex is on the circle, hopefully some of you remember, so if we say that the angle's A, then the arc would be 2A. So the angle is half the arc, or the arc is double the angle. Okay, so that's what we know coming into this. Now here we're told if a tangent and a chord, and I color coded this for you, so the tangent, remember, is a line that touches a circle once, 1 point, and a chord is a line segment whose endpoints are on the circle. If they intersect in 1 point here, on the circle, then the measure of each angle is half the arc. So that still fits into this same situation. If the vertex is on the circle, the angle is half the arc. And if we could mention that the two arcs add up to 360. These two arcs add up to the whole circle. And if we look down here, these two angles are a linear pair, and linear pairs are supplementary, and supplementary means they add up to 180. So that kind of makes sense, because these two angles intersect the whole circle, and the whole circle is 360, and if they're half, they're 180. So that kind of goes together. So let's try an example out. So they tell us that this line is tangent to the circle, and then we can see that we have a chord here, and they're asking us to find arc RT. So arc RT is this one over here. Okay, so they're asking us to find that. So there's really kind of at least two different ways to find this. So let's look at method 1 or 2. I mean, it doesn't. One way to do it. So one way to do it is we could take this angle is 102. So we could double that angle. Arc would be 204. And then we could take 360 minus 204. So we had 102 times 2. That was 204. And then we took 360 minus 204. And that would be 6. And that would be 5. And 156. Okay? So that's one way to do it. Or what we could have done was we could have found this other angle first. So that would be 180 minus 102, and that would be 78. So this angle here would be 78, and then we could double that to get the arc. So this arc out here is 156. So two ways to get that going there. And this time my camera is blocking this up here. So got to remember to check where that camera is. Alright, so let's move on down here. Okay. So line BC is tangent to the circle. Find the measure of angle CBD. So now they are asking us to find this angle here. All right. So because the vertex is on the circle of this angle, the angle is half the arc, or the arc is equal to 2 times the angle. Now, actually, because these are both even, I'm going to do it this way. So I'm going to say 3x is equal to half the arc. Now, if one of those was odd, then I probably would have doubled this side instead. Okay, but since they're both even, I can take half of 4x is 2x and half of 50 is 25. So that worked out pretty nicely. Then I'm going to subtract 2x from both sides. We're going to get x equals 25. Now, so a lot of students will stop there and they'll be like, okay, I got x, but they didn't ask for x. They asked for this whole angle. This whole angle is 3 times x. I don't think we need to put 25 times 3. If you have 3/4, that's going to be 75 cents. That already has a degree on it. Well, but it's asking for the measure of the angle, so we actually do need the degree on there. Okay, if they just asked for x, we don't need a degree on that because that already has a degree over there. Okay, if two chords intersect in the interior of a circle, then the measure of each angle is 1/2 of the sum of the measures of the arc. So it's the average of the arcs. Okay? Average, the angle is the average of the arcs. So just to try to make this a little easier to look at, I'm going to call this A and B for the measures of the arcs. So the measure of angle 1 is equal to A plus B over 2. The measure of the angle is equal to the arc. Okay? So once more, if the vertex is on the circle, then the angle is half the arc. If the vertex is in the circle, then the angle is equal to the average of the arcs. Now, if we go back real quick and look at this, that still applies up here. So here the vertex is in the circle. So this angle is the average of these two arcs. But you can see, hopefully, that that would be 90. So this would be 90. So this would be 90 plus 90 divided by 2, which would be 90. So it's easier on when the center is, the angle's vertex is the center of the circle, to just set those equal to each other. And we don't have to do this extra step. But the point is, if the vertex is in the circle, we could use this formula up here if we wanted to, just to show that the formula does work anytime the vertex is in the circle. But we should just set those equal. Okay, so one more page. All right, camera up there. Start down here. Okay, so we're just going to use that formula that we just saw there. So the angle is equal to the average of the arcs. So I'm going to write the whole formula out because sometimes we have to do a little bit more. So this one's pretty straightforward. 40 plus 120 over 2. This angle is equal to the average of those arcs. Now, because those are both even, I could just divide them both by 2 right now. So that would be 20 plus 60. And so that would just be 80. And the x already has degrees, and it just said the value of x. It didn't say the measure of the angle, so we could just say 80 there. Okay? Now, if we move over here, we're trying to find x. So this angle is equal to the average of those arcs. So the angle is equal to those arcs add together divided by 2. Now, in that case, because we just have one x here, I don't really want 1/2 x, although I could. I'm going to go ahead and multiply both sides by 2. So that's going to be 286 x plus 136. So if we subtract 136 from both sides, we get 150. Now, here, x does not have degrees on it, so we should say 150 degrees is what x equals. All right? Now, our last situation is tangent and secant lines. So remember, a tangent line, it touches in one point. So these three are all tangent lines. A secant line is a line that crosses through the circle twice. So those are all secant lines. Okay, so the difference here now is if the vertex is outside the circle, the vertex is outside the circle, then the measure of the angle is equal to, let's put A and B A and B, A and B. So notice how in all these I put A as the bigger arc. So it's always going to be the bigger arc minus the smaller arc. So maybe I should use B for bigger arc, actually. B for bigger arc. Divided by 2. So if the vertex is in the circle, we add the arcs and divide by 2. If the vertex is outside the circle, we subtract the arcs and divide by 2. And make sure you take the bigger one minus the smaller one. All right, so let's try that out. Okay. Oh, now, one more thing. If we come back and look at this special situation right here, because this circle is cut into 2 arcs, those 2 arcs added together equal 360. So in this case, they might only give you 1 piece of information instead of 2. You notice up here they gave us 2 pieces of information, 2 out of the 3. But here they could only give us 1 if they wanted to, because we could figure the relationship out between these 2. So for example, I would say that B is equal to 360 minus whatever A is. Okay. So just keep that in mind. If there's only 2, you might have to subtract from 360, which is what we have right here. So we go to start off. Here's the angle on the outside here. It looks so weird because it's pretty close to the circle. These were more moved over, but it doesn't matter. The vertex is outside of the circle, the angle that we're looking at. So 80, oh, that's x. 80 is the arc, sorry. X is the angle. So the angle is equal to the bigger arc minus the smaller arc. But I don't have the bigger arc. But this circle is only made up of 2 arcs, basically, is what I can focus on right now. So 360 minus 80 is 280. So this arc out here is 280. So the bigger arc, 280 minus 80 over 2. So we had to do this additional step here to find this arc first. But it's still pretty simple. It's just subtraction. So again, they're both even. I could divide them by 2, but I also noticed that 280 minus 80 is just 200, and 200 divided by 2 is just 100. So we could, either way, so we could do 200 divided by 2, or we could do 140 minus 40. Either way, that's 100. It already has degrees on it. It said the value of x, not the measure, so we could just say 100, and we'd be all right. Okay, here the angle, 58 degrees, is equal to the bigger arc minus the smaller arc divided by 2. So I'm going to multiply this by 2. That's going to be 116. And then I'm going to add 64 to both sides. So that's interesting. X equals 180. It already has degrees on it, so I don't need that. Now if you think about that for a second, for a few seconds, if that arc is 180, okay, so the measure of arc LMN equals 180, that means that segment LN is a diameter. All right. They didn't ask us anything about that. I'm just noticing that from there. All right. So here the vertex is outside the circle. So the angle is equal to the arc, bigger arc, minus the smaller arc divided by 2. We don't have the smaller arc, but the smaller arc is 360 minus x. 360, oh, I guess I could just write that right here. 360 minus x. Okay. So the bigger minus the smaller. Now the smaller is 2 things, so I want to put it in parentheses to help remind me to distribute. Okay. So we can do a couple things here. I think I'm going to go ahead and multiply this by 2 Just trying to think what might be clearest for you. So distribute this. That's going to be negative 360 plus x. So x plus x is actually 2x. So 2x minus 360. So I did pause there. I don't know if you noticed. I was thinking that I might just want to divide these both by 2. But if you get that and you want to do that, that's fine. I don't want to confuse anybody. So if we add 360 to both sides here, that's 500. So if we divide both sides by 2, x equals 250. And it already has degrees on it, so that's fine. All right, last two. What color am I on here? Green, maybe? Okay. Find the obtuse angle. So we got a little trick here. They gave us this over here. That's the angle we're actually trying to find, the obtuse angle. So I could focus on that. So that's what we're trying to find, but we're going to have to kind of go about it in a roundabout way. So we want to focus. We have these two arcs out here, which means we could focus on this angle or this angle, either one. So what does that angle equal? That angle equals this plus this divided by 2. Now, I really would like to add like terms in my head right there, but I won't. So they're the two arcs divided by 2. Okay? So this would be 8x plus 8 over 2, which would be 4x plus 4. So that's what A equals. Now, if you look here, these two angles form a linear pair, which means they're supplementary. We mentioned that earlier. So this plus this equals 180. Okay? So 4x plus 4 plus 12x equals 180. So that's 16x plus 4 equals 180. Now, I could subtract 4 and then divide by 16. But I also could divide this whole thing by 4 right now. If I divide by 4 or multiply by 1/4, same thing, basically, same result, equivalent. 1/4 of 16 is 4x. 1/4 of 4 is 1. And 1/4 of 180, you might not know that right away, but think about it. Half of 180 is 90, and then half of that is 45. So instead of taking 1/4, we could take half and then take half again. And that was on the screen there, not. Okay, so now I could subtract 1 from both sides and then divide by 4, and x equals 11. But they want me to find that angle. They want us to find that angle. So that's going to be 12 times 11. And maybe you know that from your times tables. I think it's 132. It's not one that we use very often, but yeah. So 132 degrees, because they asked us to find the angle itself. Okay? All right. Last one. So solve for x. So we got this picture looks kind of weird, but focus. So this angle intersects this arc over here. So the vertex is on the circle. The vertex is on the circle, so the angle is half of this arc. But over here, if we look at this angle, the vertex is on the circle, so it's half of that arc also. So we could double this and get 8x squared and then realize that this angle is going to be half of that, or we could realize that both of these angles intercept the same arc and both of their vertices are on the circle, so these two are going to be equal. So this is also 4x squared. Now that's helpful to us because now we're trying to solve for x. Here we have another linear pair, so if we add these together we get 180. So 4x squared plus this, which I'm going to rearrange a little bit, plus equals 180 because they form a linear pair. Well, here. We could do here as well because those are vertical angles, and then we could do it here, but it doesn't matter. Same thing. So if we subtract 180 from both sides, that's 10. Okay? Now, I'm going to try and factor this again. If it doesn't, we can always use the quadratic formula, just sometimes the numbers get kind of big. So if we try to factor and it doesn't work, we could switch to quadratic formula. So we take 1 over whatever that is, and then we put that on both of those. This is positive, which means they need to be the same sign. This is negative, that means they both need to be negative. A times C is 40. So I need factors of 40 that add up to 13. I think you ought to be able to find that pretty quickly. That's going to be 5 and 8. 5 times 8 is 40. 5 plus 8 is 13. And they're negative in here, so that's fine. So I can divide this by 4. So that leaves us with 4x minus 5. And if I divide that by 4, that leaves me with x minus 2. Okay, so our solutions for that, add 5 and divide by 4. So that's 5/4. And here just add 2. So remember, what we're doing there is, this is the zero product property. If A times B equals 0, then A has to equal 0 or B has to equal 0. So if you needed to, you could set that equal to 0. 4x minus 5 equals 0. And then solve it. And then you want to plug those back in and check. And they actually both work. No problem. So the question just has to solve for x. So we're done. All right. It's about that time. Have a good day.